Good morning, everyone. In this class, we'll start discussing about two different type of flip-flop. They are called the D flip-flop and T flip-flop. So the D flip-flop, which is also called the delay flip-flop or data flip-flop, which is a modified version of clocked RS flip-flop, which we already discussed in the previous classes. So in this case, in a clocked RS flip-flop, the R and S terminal will be connected together, whereas it will be inverted. The one of the terminal will be there is an inverter will be used and so that there will be only one input. So the one input which is given to the terminal, for example the S terminal, in this case we call it as D terminal, and the inverted of that, in the inverted version of that, will be given to the corresponding R terminal, so that there will be only one input. So the advantage of this type of flip-flop is that we can avoid the uncertainty conditions, the forbidden conditions when both the inputs are high, which is not allowed. But when we are complementing the inputs, whenever there is a one state, the other input will be 0. So it will be avoided. And there is another type of flip-flop which is called the T flip-flop, which is also known as toggle flip-flop, which is a modified version of JK flip-flop. So in JK flip-flop, these two terminals will be connected, that is the J equal to K is equal to T. So that is a single input, and depending on the input and clock pulse, you will get the output states. So we will discuss about these two type of flip-flop in this class. So as we discussed, the D flip-flop, which are also called the delay flip-flop or data flip-flop. In a simple RS flip-flop, which requires two inputs, one to set the output and one to reset the output. By connecting an inverter, as you see here, by connecting an inverter to the RS flip-flop, we can set and reset the flip-flop using just one input, as now the two input signals are complemented of each other. So if you are giving one here, that the 0 will be going here and 1 will be going here. So the condition of both inputs high will be avoided in this case. So it is a one of the important clock flip-flop, as it ensures that there is never both inputs are never equal to 1. So here is the symbol of the D flip-flop, and as you see here, which has got two inputs. One is the clock input and other one is the data input, and there are two outputs. One is the output normal output Q, and other one is the inverter of that. And you can also see the logic diagram here. So this is the normal clocked RS flip-flop. If you are giving one input here and another input here, but we are going to give input only to one terminal, and the inversion of that will be given to the second one. So it is constructed from a RS flip-flop with an inverter added between the S and R inputs in order to allow for a single data input. The D input is passed on to the flip-flop when the value of clock pulse is high. So it will work only when the clock pulse is high. Otherwise, these two AND gates will not work, right? So when we don't apply any clock input to the D flip-flop, there will be no change in the output. So output remains the same. So we can see this is the truth table for this kind of flip-flop, and you can see here when the clock signal is low, the output remains the same. So there is no change irrespective of what is given to the D input. But when the clock pulse is high, and if you are giving 1 to D, that is corresponds to the set condition, that will be transferred to the Q output. So whatever we are giving to the input when the clock is high will be transferred to the output. So this is the normal output Q1 and other will be 0. And in this case, when clock pulse is high and if you are giving 0 to the D input, you will get 0, that is the reset conditions. So out of the D flip-flop, which takes the state of D input at the moment of positive clock pulse, that is when the clock pulse is going high, and delays it by one clock pulse. So the output will change only after one clock pulse. So it will change only when there is a clock pulse. So that is why it is also known as the delay flip-flop. Now let us talk about the T flip-flop. So the T flip-flop, where the T stands for toggle. This is a much simpler version of a JK flip-flop, and both the J and K inputs are connected together, and thus are also called a single input JK flip-flop along with a clock input. So instead of giving independent J and K values, these two are directly connected. We can say that the flip-flop, which is a single input JK flip-flop, or which is this flip-flop will be only having two conditions, or two way of operation. One is the toggle operation, and other one is the hold operation. The toggle means the output keeps changing when there is a clock pulse, but the hold condition means the output remains the same when there is a clock pulse. So that state will depending on what is given to the T terminal. And here you can see the symbol for this T flip flop, and there is two inputs. One is the toggle input, and other one is the clock, and the outputs are the normal output and the inverted output, and this is the logic diagram. Yeah, it is exactly same as the JK flip-flop. The only difference is that these J and K are connected. So this is J is equal to K is equal to T. Okay. The operation of T flip-flop, which is almost same as the JK flip-flop, as I just mentioned, the only difference is J is equal to K is equal to T. So we eliminated the other two combinations of J and K, for which those two values are complement to each other. So the 1 0 and 0 1 conditions we eliminated. In this toggle flip-flop, when you provide a logic high input to the T flip-flop, if the output is currently at logic high, it changes to logic low. If it is currently logic low, it changes to logic high. So a logic low input causes T flip-flop to maintain its current output. So you can see it here. When the when we are giving T input 0, if you are giving T input 0, whatever is the state, the current state of the Q, which remains the same. So when there is a clock pulse, whatever is the input here, which will be remains the same. And if it is 0, it will be 0, and when T is equal to 0, if Q is equal to 1, the next state will be same, the 1. But if you are giving T is equal to 1, when the input is logic high, the presence, if there will be a toggling. So if the present state is 0, that will change to 1, and if it is 1, it will change to 0. So toggling will happen. The toggling will happen when T is equal to 1, and the hold condition will occur when T is equal to 0. So this is different from D flip-flop, where whenever there is a clock pulse, the output will be same as D input. Whatever so these conditions we apply when logic high clock pulse. So whenever there is a high clock pulse in D flip-flop, whatever given to the D will be transferred to output. So if D is equal to 0, the output Q will be 0, and if D is equal to 1, output Q will be 1. But in this case, it is not like that. So that depending on what is input to the T. If input to the T is 0, it will the whole condition. So whatever was the previous input, output, that will be remains the same, and if it is T is equal to 1, that corresponds to the toggling condition. So output will change. So this is not directly connected to what is given to the T input. So that depends on the previous states also. So in this kind of toggling flip-flop, when you provide a logic high input to the T flip-flop, the output is currently logic high, it's changed to logic low, and if it is logic low, it's changed to logic high. So when input is logic low, when T input is low, output remains the same. So that is corresponds to the all conditions. I hope it is clear, this explanation is clear to you. And let us discuss what are the difference between these two type of flip-flop, the D flip-flop and T flip-flop. In the case of D flip-flop, when the clock rise from 0 to 1, the value remembered by the flip-flop, which becomes the value of the D input at that instance. Whereas in T flip-flop, when the clock rises from 0 to 1, the value remembered by the flip-flop either toggles or remains the same depending on whether the T input is 1 or 0. So the D flip-flop, which is the data type flip-flop, which means the output only follow input but in synchronization with clock and hence delayed by a clock pulse. Its output doesn't change if the clock is disabled. Whereas in T flip-flop, is toggles the flip-flop, which complements its output when the input T is equal to 1 and keep its output unchanged for the input T is equal to 0. Thank you.